Okay, we are, let's see, on page 50. Ooh, that seems monumental. We are talking today about mean absolute deviation. And now that I just wrote that, we might actually fit that on 49, but we'll just see what happens. Let's see what happens. The nice thing is if you have been taking notes all the way along, you have a great resource to take to 7th grade. Let's just do page 50 because this might be a big one. All right, so we start with mean absolute deviation. Now, these words are, some of them are familiar. So mean, you already know, right? Mean we talked about on page 48. And it's when you add them all up and divide by the number of numbers. Okay? Absolute is, we're thinking back to when we talked about absolute value, which we did on handy dandy 35. And remember the absolute value is the distance from zero. Now in this case, it's not going to be the distance from zero, it's going to be the distance from the mean, but we're remembering it's distance and it's always positive. And the last word might be new, and that word is deviation. So deviation means you're different. If you deviate from the path, that means you wander into the forest. So deviation is how different one thing is from another, or one experience is from another. So if someone is a real deviant, they are very different. And if someone is pretty, like, they don't deviate much, they don't differ from other people. So the mean absolute deviation is not hard, it's a lot of steps. And anything with a lot of steps has a lot of ways it can go wrong. So this is what we have to be careful of. So first, I have this data that I recorded from the rock tumbling activity in science. So meters traveled by rocks. This is my data set. So step one of finding the mean absolute deviation is to calculate the mean, which makes sense because it's the first word, first step. And you'll notice when we take notes, we always include an example, and that's so you can look back. You have something to refer to. So to calculate our mean, we need to do 375 plus 499 plus 395 plus 492 plus 484 plus 407 plus 501 plus 350. Figure out what that equals. Three, 5 plus 499 plus 395 plus 492 plus 484 plus 407 plus 501 plus 350. All right, we get 3,503. That is not my mean though, right? Because now I need to do that sum divided by the number of values I had. In this case, I had 1, 2, 3, 4, 5, 6, 7, 8 values, so I need to divide by 8. I'm kind of evening out, finding the balancing point. 3503 divided by 8 equals 437.875. We're going to round this to 438 to make our lives easy, because we're about to do a whole bunch with that number, so 438 is the mean. All right, step 2 now is to compare each value, each data point, with the mean, and find the absolute distance, meaning it's always going to be a positive number. So this is the absolute part of the equation. So one of my data points was 375, so I'm finding the difference from 375 to 438. Now in this case, 438 is bigger, so I can either do 438 minus 375, or I can do 375 minus 438. Even though it's negative, I'm just going to remember that absolute value is always positive, so this is 63. I'm going to do the same thing now for the next value, which is 499. You will never have to do this without a calculator, so don't worry about that. And it is a lot of steps, and if you don't use a calculator, it'll take you 150 years, so I recommend that. Remember, this is a negative number, but I'm just going to remember the absolute value is always positive. Where did I get? Oh, 395, 492. And if this seems repetitive, it kind of is. When we're doing this, what we're figuring out is how different each number is. How much does it stray from the mean? If we have a big absolute value, the bigger the differences are, the more different the data is from each other. If we had a data set where it was all exactly the same, that would, the deviation would be 0 because nothing's different. In case you're wondering, why is it that we're writing 438 over and over again? It's because it's the mean, and we're comparing all of these with the mean, which is why step number 1 has to be finding the mean. We have nothing to compare it to. That can't, oh yeah. First I thought that can't be right because we already wrote 63, but this one was 63 under and this one was 63 over. Good life lesson for me. Is it 350 compared to 438? 88. All right, so these right here are all the deviations. Which is how far each value is, or how different. I'm going to change that. How different each value is compared to the mean. All right, step 3, we're almost done. Step 3 is to find the mean of the deviations. So it's kind of like finding the mean of a new data set, and the new data set is all the numbers of how each data point was different than the mean. So I'll read these off to you. I have 63, 61, 43, 54, 46, 31, 63, and 88. And I find the mean again. So I add them all up. 63 plus 61 plus 43 plus 54 plus 46 plus 31 plus 63 plus 88. I'm going to find the sum of that and divide it by, if I had 8 values over here, I'm going to have 8 values over here because there's one for each number in the original data set. Yep, 8. All right, let's add again. You're always going to be able to use a calculator on these because holy smokes, a lot of steps. 8 equals 56.125. We'll just round to 56. So what this tells us is each value in the data set is about 56 away from the mean. This is a measure of variation. This is one of our MOVs, so our measure of variance. So it probably makes sense to put a note over here that says mean absolute deviation. You can remember it because it's probably going to make you mad. Is also a measure of variance. So here's what this data means. If we had a data set where the mean absolute deviation was 1, that tells us that that data is very close together. It's very similar. We have something with a mean absolute deviation of 100, that tells us that the data is very different. It's spread apart. The reason I might want to know this is, let's say that Mr. Burkholder comes in and wants to know about my teaching and says, all right, I want to make sure you're teaching your kids. What's your average exam score? And I say 80. 80% is my average exam score. And he's like, okay, that sounds okay, but what is your mean absolute deviation? Meaning, how many kids are scoring in that range? So if I say my mean absolute deviation is 5, that means most of the data is close together. Most of my kids are scoring right around the 80 mark. But if I say the mean absolute deviation is 30, that means I have some kids scoring way higher and some kids scoring way lower. And then he might say, okay, that tells me that maybe you're not being a very effective teacher for all kids. So we would need to look at that. So when we take this with the measures of center, this tells us a lot more about the data set. There is one last thing I want you to know about mean absolute deviation, and that it is called, once you get out of middle school, it's typically called standard deviation. So like alias, like a name that spies go by. The alias for mean absolute deviation is standard deviation. So if you hear about standard deviation, you now know how to calculate it, which I did not learn until I was in college, no joke. So You're ahead of me, but I like the title mean absolute deviation because it kind of reminds you of the steps. So that is mean absolute deviation.